Hi, in this video we're going to see how the tool Traceroute works. First of all, a brief review of what we know about Traceroute. Uh, Basically, it's a tool that shows the road traversed by IP packets from a source to a destination and also give us some information about transmission delay. So we're going to see how this tool works in an example network, which is this one you can see in the slide. We have two hosts, source host with address A and a destination host with address H, and a number of routers. And we're interested in, we're going to send packets traversing this road that you can see now, which goes through R3, R4, and R2 to finally reach destination host H. And the IP addresses that are going to be involved in this path are A, B, C, D, E, F, G, and finally H. As you probably remember, Traceroute makes a number of attempts to send the packet to the destination with increasing TTL values. So we're going to see the first attempt, and in this first attempt, A is going to send an IP packet to H with a TTL value of 1. So this IP packet is going to reach router R3, and router R3 is going to decrement the TTL value to 0, and since it has reached 0, it will simply drop the packet. Since the packet has been dropped, R3 will notify the source host A with an ICMP packet with source address B, specifying that the TTL of this packet expired, and it will send it back. So now A is going to make a second attempt, and in this second attempt, it's going to send the same IP packet, but in this time with TTL equal to 2. So this packet will reach R3, which decrements the value of the TTL, and then forward it to R4, which in turn will also decrement the TTL value. Now the TTL value reaches 0, so R4 drops the packet. And in consequence, R4 is gonna send an ICMP TTL expired packet back to A with source address B, because B is the source address of router R4. So there it goes. Note that the ICMP packet also gets a TTL value, which is decremented in the transit, but this TTL value is high enough so that it can reach the destination without a problem. So now A is going to make a third attempt, in this case with TTL equal to 3. So again, it gets to R3, which will decrement the TTL value to 2, then R4, which will decrement the TTL value to 1, and then to R2, which will decrement the TTL value to 0. So now the packet, it's going to be dropped, and a TTL expired ICMP packet is going to be sent back to A from destination F. And you can see it travel with the adequate decrementation of the TTL values. Okay, so now, fourth attempt. Now A is going to send a datagram with TTL equal to 4, which again is going to be hopping from router to router, and each router is going to be decrementing the TTL value. And in this case, finally the packet is going to reach the destination host H. So now it's time to see what happens with the data in this IP packet. Normally, the data that this IP packet carries is a UDP datagram to a very high port, normally 33434, which will be a port where no service is listening. As a result, since there is no service listening in port 33434, 3.4, H is going to send back an ICMP packet, which is called unreachable port, with source address H. And this ICMP packet will travel again, jumping through the network through the 4 routers again, getting finally back to A. So from the information in these ICMP packets is how A is able to get information about the route. Actually, each attempt is repeated 3 times, and the times that takes the packets to go back and forth from source to destination or to intermediate router and back, these times are recorded. So you can see here an example of what will be the output of Traceroute from this particular network, and you can see that there are 4 entries, one for router 3, one for router 4, one for router 2, and finally one for host H. And you can see the different times for each of the attempts. And this is basically how Traceroute works.